Patrick Cook here. Welcome to Devlog number 2 of Project GBPL. This project explores how 3D game technology can be leveraged for learning real-world photography. And that was pretty well discussed in Devlog number 1, if you have a chance to review that. This Devlog goes into how well the in-game camera's behavior simulates real-world camera. Now, if you recall from Devlog number 1, I went down through a number of different criteria that I felt were important for this project's success. One of those criteria that was very important was that the in-game camera closely simulates the real-world camera. The idea is that if the in-game camera can simulate the real-world camera, learning photography or learning the use of the camera, which is also learning photography, is greatly enabled. Now, what we're going to do in this devlog is demonstrate the behavior of a real-world camera. I have 2 cameras that I've set up out of doors. One is a Dslr and the other is a mirrorless. And what I want to do is to go through and actually demonstrate how each of these cameras behave in terms of their exposure settings and see whether or not the game replicates or simulates the behavior of a camera. Now let's start with my Canon 6D DSLR. The Canon 6D is probably about, I don't know, maybe 8-9 years old. Here you see that I've set up the camera for f/22, which would give me the smallest aperture opening. And what I've also done is I've set up the shutter speed so that I get a exposure compensation meter is about centered. Now we're working with ISO 100 at the moment. Now, if I take a shot, you'll see that the f/22 has given me a large depth of field. A depth of field is the range from the lens of where to beyond the lens, where you're going to get a reasonably sharp focus. Now next, let's go into the DSLR and let's set the aperture to 4. Now you see that my depth of field is very shallow. And so the point of this exercise is to show that f/22 and f/4 will produce different depths of field, or that it would be the range in which you have reasonably close focus. Now let's do this. Let's take the same camera and let's go to kind of a middle aperture, say f9. All right, now so I get the exposure meter centered by adjusting the shutter speed to 40. Now I have a reasonably good depth of field. I basically have a compromise between the foreground focus and the background focus. Well, anyway, this is a typical behavior of a physical camera that is in manual mode. All right, now let's change the ISO. Let's go for, say, 1000 ISO. Now, the point of this exercise is to illustrate that ISO is part of the exposure adjustments of a typical physical camera. And you can see here I still had to go through the process of setting up my my aperture and my shutter to get a reasonably good exposure. Now I'm going to set the aperture down to 4, and I should expect a shallow depth of field, and I do. Okay, so the background is somewhat out of focus, and the foreground is reasonably in focus. I have a shallow depth of field. So if we just pop into the game here briefly, if I set up my aperture so that it is very large, or a small number, a large aperture, then go ahead and adjust my ISO and get the exposure compensation set up so that I get a reasonably good image. And I'll set up the focus distance so that I can be able to demonstrate that the small aperture is going to give me a shallow depth of field. So that tracks nicely with the DSLR camera demo that I just did. Now if we go back into the settings, and we're in the game now, and I set the aperture to be a very small aperture or a large number. I'll go for f/22 all the way to the max that this can do. And go ahead and set the ISO, and I want to set my exposure compensation so that I get a reasonably good exposure within the game. Now what I should find is that I have a very large depth of field where the background is in pretty good focus and the foreground's in pretty good focus. So the game tracks the behavior of a physical camera quite well. All right, now let's fire up the Sony a6000 mirrorless to be able to demonstrate exposure behavior with a mirrorless as well. The first thing I'm going to do is I'm going to go for a very large aperture, which would be an f/3.5, which is what this particular camera and lens combo is capable of. I'm going to go ahead and set the shutter so that I get a reasonably close centered exposure. All right, so reasonably good. I got a shallow depth of field. The background is somewhat out of focus. The foreground is in fairly good focus. I get a shallow depth of field. Now, let's go all the way to f/22. We're going to get the smallest possible aperture that this camera can handle, small in terms of its aperture opening. Now I'm going to modify the shutter speed so that I get a centered exposure. And then I'm going to take a shot, and I find that I have a large depth of field. This is the behavior of the combination of the aperture, the shutter speed, and the ISO in terms of the optics of the lenses and the body of the camera. All right, so now we're going to do an experiment where I'll try to demonstrate that the camera will try to achieve the best focal point based upon the depth of field that is established by both the aperture and the shutter and the ISO. The first thing I'm going to do is set this to a very large aperture or a low f number, f-stop, set the shutter speed so that I get a reasonably good centered exposure. Now what I'll do is I'm going to go into the focus mechanism, and I'm going to see if I can find a good compromise between the foreground and the background. Now keep in mind that my aperture has been set up to basically give me a shallow depth of field. But now I've set up the focus. So now I'm going to go into my my controls, and I'm going to increase the aperture setting. I'm going to up to f22, which is going to give me a very small aperture, which should give me a very large depth of field. All right, and center my exposure using the shutter control, and here we go. So I have a large depth of field. I got a good, reasonable focus on the background and good focus on the foreground. What this demonstrates is that at the time of the shot, the camera will try to achieve the focus on your scene according to the aperture setting, which determines your depth of field. All right, well, let's hop back in the game now, because that's the point of this project. What we've done is gone through the DSLR and the mirrorless, and we've shown how the exposure controls can be adjusted in manual mode now, of course. And what we wanted to show is, primarily for the purposes of this devlog, we wanted to take a look at how aperture affects depth of field. All right, so a large aperture, a small f number, say f1.2 with 3.5, will tend to give me a shallow depth of field, whereas a small aperture with a large f-stop number, such as 22, will tend to give me a large depth of field. Now, what we want to know is the game camera behavior closely following or simulating the behavior of the real-world camera? So I'm on the map now, and this is the city park asset, which I did refer to and talk about in devlog number 1. Now, let's fire up our camera and see whether or not we can achieve a similar depth of field effect with our in-game camera. All right, let's start with a very large aperture. That would be a small f-stop number, and I'm just going to go ahead and fine-tune these so that I get a reasonably good exposure. We don't want something too bright and too light to work with. We want a reasonably good. I'm going to adjust the focus distance here, which this application gives me the ability to do. Now if I take a look at my image, we can see that the background is out of focus and the foreground is in focus. So we have a shallow depth of field, which we anticipated getting with an aperture of 1.2, a very large aperture. Now, let's set this to f22, and let's just kind of tweak the exposure so we get a fairly decent exposure. What we should get, if it follows the behavior of a real-world physical camera, we should have a large depth of field. And we do. The background is in reasonably good focus. The foreground is also in reasonably good focus. So this seems to demonstrate that the in-game camera, simulated camera, closely follows the behavior of a real-world camera. Now, that's super critical to this project, because how are you going to learn photography in a simulated environment if it doesn't behave similar to the real-world camera? Well, all right. I think that accomplishes our objective for devlog number 2 of Project GBPL. The idea is that we need a in-game camera that closely simulates a real-world camera in order to optimize learning of photography, which is what this project is all about. Hey, listen, I'd love to entertain development collaborators. If you want to get involved with the technical side of this project, I'd love to see community discussions get up and running. Let's talk about the project and what it can do and where it can go and what it can accomplish. And I'd love to see your contributions to this project. So join me up on Project GBPL up on Discord. The link is in the description of this YouTube video. So as always, thank you very much for joining me, and thank you very much for your interest in Project GBPL. You take care. Bye-bye.